We've learned about percentages. Now we want to talk about applications of percentages. Where do we use them? How do we use them? So let's look at our objectives for this video and for this section. After you're done with this video, you should be able to calculate the percent increase or decrease of an item, determine the commission rate on sales at a given rate, calculate the amount of sales tax on an item, and calculate simple interest on a loan. So when you get through the end of this video, if you're not sure how to do any of them, you're going to want to go back and watch again. The first scenario is we see and use percentages all the time when we are shopping. T-shirts for sale, beanies. Alright, my favorite, Home Depot, we see a price cut, $139 down to $69.88. Sneakers, another sale, coupons for 40% off. So the question is, we see all of these things when we go shopping. How do we determine what's the best deal? What is the discount that they are really giving to us? Let's go back to this example. Since I like to shop at Home Depot, we'll look at this. The original price was $139. The new price is $69.88. So the question is, what percent discount are we actually getting? We talk about percent change, which is the ratio of the amount of change to the original amount. Remember, a ratio is comparing two numbers. So what we have, percent change, the amount of change over the original amount. And in this situation, the amount of change is already calculated for us. We have $69.12, and then the original amount of $139. So we divide these numbers. That's going to give us our percent change of 49.7%. Now, when we talk about percent change, we have two options. The original value can go up or it can go down. When the value goes up, we call it percent increase. When the value goes down, we call it percent decrease. Pretty simple. So let's look at an example here. Let's say John owns an auto parts store, and typically he marks up his merchandise by 36%. So he buys things, increases the price, so we would have a percent increase of 36%, and sells it to customers at that new price. So the question is, if he buys a part for $58.75, how much would he charge a customer? So let's look at this. Remember our formula. Percent change equals amount of change over original amount. So we start with our formula. We fill in the parts that we know. Our percent change, 36%, when we write that in a formula, it's going to be 0.36. Now the amount of change is a little tricky. The amount of change is the difference between the new price and the original price. So the new price is our unknown. We know the original price in this situation. So we have new minus 58.75. Now the original amount is 58.75. So we're going to solve for our new variable. And when we do that, we will find that new equals 79.90. So John buys a part for $58.75. He marks it up by 36%, and he sells it to the customer for $79.90. All right, next we want to look at commission. Most people that work in sales have a base salary or base rate, but they receive a majority of their income based on commission. A commission is the fee paid to a person who makes a sale, and it's usually a percentage of the sale price. This percentage is called the commission rate. So let's look at the formula that we want to use to calculate our commission. Commission rate times sales equals commission. So for example, if I'm a salesperson with a commission rate of 4%, If I sell a computer for $899, what will my commission be? Again, we look at our formula. Commission rate times sales equals commission. Our commission rate is 0.04, 4%. We're going to multiply that by $899, and that's going to give us our commission, which equals $35.96. So, if I sell a computer for $899 with a commission rate of 4%, my earnings or my commission would be $35.96. Another place we deal frequently with percentages is with sales tax. This is the tax on the sale of an item or a service, and it's the percentage of the purchase price that is collected by the seller. Now, no one likes to go shopping, get to the checkout, and discover they don't have enough money. We can help avoid this by estimating and keeping track of sales tax while we shop. So as we're going through the store, we pick up something that's $10 and we say, okay, what's the sales tax on that? So if we buy a bike for $230 in a state that charges 7% sales tax, we need to make sure that we have more than $230 when we head to the checkout. Our total price would be the $230 plus the sales tax. We calculate the sales tax by the total amount of the purchase price, so $230 times 0.07, which is 7%. So if our bike has a price tag of $230 with a sales tax of 7%, then when we get to the checkout, we're going to need $246.10. The last example we want to look at is interest. If you borrow money from a bank, you pay interest for the use of the bank's money. On the flip side, if you deposit money at the bank in a savings account or even some checking accounts, the bank is going to pay you interest on the money that they're keeping for you. There are many different types of interest, but we are only going to concern ourselves with what we call simple interest. And that's because it's simple. So let's look at the formula and the different parts to calculating simple interest. Here's our equation. We have 4 pieces. We have simple interest. That's what we're actually trying to calculate. And again, it's one of the forms of interest. So interest equals capital P. P is the principal. This is the amount of the money that we're borrowing or we're investing in the bank. And the next thing, we're going to take P multiplied times the rate of interest, R. Rate of interest is the percent interest, or the percent that is charged or earned. And then finally T for time, and we're going to deal with time in the form of years, but you could change the time depending on what your interest rate specifies. But time in years that the money is borrowed or invested. So again, if we summarize our formula, it's interest equals principal times rate of interest times the time in years. Now suppose a bank offers an annual simple interest rate of 8% on a loan. If you borrow $15,000 over a period of 4 years, how much will you have paid back in the end? So we set up our equation. Interest equals principal times rate times time. And in this case, we plug in the values 15,000 times 0.08 times 4, which gives us a total interest of $4,800. Now, we're not done. This is just the interest that was paid. So if we want to look at how much we will have paid back in the end, we borrowed $15,000. In the end, we need to add $15,000 plus $4,800, which gives us a total payback of $19,800. Now, that wraps up all the different types, but we're just going to do a quick review. So we have percent change, which is the ratio of the amount of change over the original amount. We have the commission rate. times the sales, which equals commission. And then we have simple interest, which we just looked at. Interest equals principal times rate times time. Now, go ahead and log into Moodle. Answer the few questions that are there. If you understood everything in the video, this should be a piece of cake. If not, feel free to go back and watch the video and listen and look at the examples as many times as you need to. We'll see you in class.